I know you have no clue what this is on the board. Okay, so that's what you're learning today. And by the end of the hour, you'd be able to go, oh yeah, literally about 35 seconds or so from seeing this problem, you'd be like, yeah, there's no solution to this one. And the remainder is 1. Now, you have no idea what's going on yet. Let's back you off to like something you could do. What if I said 7 goes into 73? Would you do that? Do it with long division, and let's remind you yourselves of the steps on when it's easy. And then we'll slowly work our way into reviewing for the test, which is coming on Thursday. Holy cow. One more day of new material after today. All right. So first off, did you realize that 7 went into 7? You don't go 7 into 73. You go 7 into 7 one time, and then there's a 7 here. Draw a line. Make it the opposite. Notice I'm not saying subtract, because sometimes you're turning a negative to a positive when you're doing the polynomial kind. So I say make it the opposite, and then I say combine them, because this isn't always subtract, because sometimes you got a positive and a positive. So anyway, final answer here, 0. Bring down the 3. Does 7 go into 3? No, and therefore that's the remainder. But I thought you put a decimal. Yeah, if you were going to get a decimal, you could at this point put a 0 here, but don't. Because in polynomial or long division, there's no decimals. All right. So if this goes into 3 0 times, you'd put a 0. Because the answer wasn't 1. I mean, does 7 go into 73 one time? No, it went in 10 times. Okay. All right. Now let's see how that is kind of like the old factoring, but with long division. See if you learned how to factor with long division by attending my class on, what was our last day? Was it a Thursday or a Friday? No, it was a Tuesday. That's right. Holy cow. On Tuesday of last week, I taught you this. Jaden. I do. They're up on my desk. Just grab it. I got a 0 at the end. That means it worked. And that means I got to give the answer. And if I leave it like this, tragically, it will be marked wrong. Because the answers are going to say, put your answer in factored form. So right after it, you're supposed to put x plus 1 times x minus 6, and see, it equals that. That's the beauty of this, is it just says equals that times that. My one looked kind of funny there. I'm going to fix it. There we go. Now if they ask what kind of roots did it have, you could say it had 2 real roots. And they were what? X equals -1 was one of the roots, and the other root was x equals 6. What are these roots you're talking about? They're the same thing as zeros. They're the same thing as solutions. You know what they're not exactly the same as? X-intercepts. Because, see, an x-intercept would have to have comma 0. If it was an x-intercept I was writing, I'd write -1 comma 0. That'd be different. All right. Imagine a world where you just got done factoring and you got this. How many roots do you have? Yes. 4 roots. Very good. By the way, that's the same as the degree that this would have been. If this was multiplied all the way out, can you imagine a world where you'd multiply this all the way out and you'd have an x to the fourth at the beginning of it? By knowing that, you also know, this is a review time, that there is a graph that would be going up on the right. Do you remember what part of this is telling me that the graph is going up on the right? Avery? Yeah, that number in the front, it's technically called its lead coefficient. Very good. The lead coefficient is positive and therefore it's going up. The fact that the degree, do you remember that word? The degree is 4 and the degree is even tells me that it's also going up over here because even would imply the same. Is all this ringing a bell? And then the last thing is take 2 seconds and figure out the y-intercept. Hint, the y-intercept is where x equals 0. If you go put a 0 here and here and here, you'll get -1 times -1 times 4, which is 4. So 4 is your y-intercept. Then last but not least, this is telling me it's got an x-intercept of -4, which is like maybe that's the one that's over here. And this one is telling me it's got an x-intercept of 1, which is like maybe right there. And that is not necessarily how it for sure looks. Why? All right, there's one more thing. Did anybody catch that this part could be factored further? Awesome. Then you knew that there was another x plus 1 and another x minus 1. And so that introduces one more root. There's one at +1 and there's one at -1. So there's another root like right here. So all right, and that isn't even the final answer to how it looks. But I just reminded you of a whole bunch of things. Like you got to be able to factor that further. That the thing in the front is positive means it's up on the right. The fact that the biggest degree you have is, the whole thing is degree 4, means it's also up on the left. And this is getting way too far into the review part. So I want to get back to the normal. Everybody go to this page. And I just tried to remind most of these things, but I'm going to just show you one last thing. Don't write this. This is rare. Just watch, because getting bogged down in the details here won't help. Does this have a missing term?
Yes.
Yeah, it goes from the 4th to the 3rd to the, oh, there's no x to the 2nd. You got to be watching for those in today's lesson especially. So then you'd go plus 0x squareds, and then the plus 4x, and then the plus 1. Notice, put a 0x in for any missing term, and the squareds were missing. All right. Next thing. This has got 1, 2, 3, 4. Once it gets that big, you don't call it a binomial. You don't call it a trinomial. You call it a polynomial. Very good. So this is a polynomial with degree 4. And it's got a y-intercept of 1. Is all that making sense to you? Since it's positive, it's going up on the right. Since that's even, they're both going up, left and right. Okay, enough about the review part. Let's go on to this page. Now let's just make sure you know how to do long division like I taught you on Tuesday. And I totally get it. You've had 5 days to forget. So I'll help you get this first one going. You put an x plus 1 here. Draw the little house. And I said it was like a cave. And a bear could have a den in there. And that's the thing in the inside. It's called the dividend. Because it's like a den. Jaden, what do you always start with on the top? You do try the x, but then you'd realize on this one that isn't enough because you go that times that. So x squared. If anybody still has their phone out on their desk, just absent-mindedly, make sure you put it away. Should not have that out at this time. All right, that x squared times the x makes x to the third. And then the x squared gets times by the 1. And you get plus 1x squared. Draw the line, opposite, opposite. Don't forget that. It's so easy to forget that. 2x squared minus 1x squared is just x squared. Bring this down. So plus x up here because x times x will make x squared. And you want those two to match up. X times 1 makes 1x. Right here, last hour, I think, is where I forgot to put a negative in on both of them. It's so easy to just once forget to put negatives on both of them. And then this makes negative 6x. Bring down the minus 6, and it's going to work. Because I can put a minus 6 here. And minus 6 times the x will make minus 6x. Minus 6 times the 1 makes minus 6. Draw the line, opposite, opposite. And I get 0 remainder, yay. And if you leave it like this, I cry a little bit and mark it wrong. Because the directions will say, make sure your answer is in factored form. And it might even be nice and say fully factored form. So who caught it? If you don't know what it is, then you didn't know what I'm talking about. What did you catch?
The x squared plus x minus 6 can still be factored.
That gets factored again. It's so easy to not notice that. You were maybe one of 2 people in the whole room who noticed that that could be factored again. And that's going to happen on your next test. You really got to check. You got to go, is it factored all the way? Because you get all that work of factoring with this ridiculous long division that takes so many steps, and then you get the answer wrong because you didn't do the simple factoring. Because there's a minus in the problem, I put a minus here. Because I can't put a minus here because that wouldn't come out negative, so I make a plus there. And then it must be a 3 and a 2. I want the bigger one to be positive, so that's 3, that's 2, there we go. How many roots does it have? 3. How many of them are real? All 3 of them. How many of them are x-intercepts? All 3 of them are x-intercepts. The only kind that wouldn't be x-intercepts would be the kind that have imaginary answers, like try putting in something that will make that equal 0. You'll never find it unless you use imaginary numbers. That'll make that right there. This is a completely different answer, by the way. They're not the same at all. Different problem. But if you had this, do you get this part has imaginaries?
Yeah.
And this part has reals.
Yeah.
All right. One last thought. Little thing, but it can make a big difference. Imaginaries always come in sets of 2. You will never find one imaginary answer. Think about, if I found an answer that would work in here, then couldn't it have a plus and a minus of that number? Yeah. They're always going to be 2. If there's imaginaries, they come in sets of 2. It's kind of like deer running across the road. It's so true that if you see a deer running across the road, you should be like extra careful because so often they come in sets of 2 or 3. Because it's a mama and babies a lot of times. And so if you see a deer run across, don't think, "Oh, I'm safe. This is great." Think, "Where's the other deer?" It's really true. I have only had, I think it's 4 accidents in my lifetime, 3 of which were a deer running out in front of me or a deer running into the side of my car, which is so weird to have. I didn't even hit it hit me. So like I'm driving along and it was like trying to run out in front of me, but it didn't go fast enough, and so it just smashed into the side of my car. So anyway, if you live in Minnesota long enough, you're pretty likely to hit a deer. One last thought on the deer thing, because all of you at some point are going to have a deer run out in front of you when you're driving. And the best thing to do is to just hit the brakes. Do not try to swerve to miss the deer. My dad lost one of his friends that way. Deer ran out in front of him. He swerved like, oh, just automatic reaction, like, I don't want to hit the deer. Guess what he hit? A semi. Head on. Dead. Boom. So, moral of the story, I know you want to be nice to the deer, but it also happens that people go the other way and they swerve to the right and they go into the ditch, and then you can roll over and die, or you can hit a tree and die. So you're more important than a deer, in my opinion. And so you should just hit the brakes. You don't want to try to hit it. Hit the brakes as hard as you can, but don't swerve to the left or to the right. You got to, just because I know multiple people that have gone in the ditch. Maybe not, I don't know anybody that's died, but I've seen multiple people go in the ditch, and one person that I've, kind of a friend of the family thing, died. Okay, so I know it's a little off topic, but you will all experience it at some point. Just try to remember, don't swerve. All right, let's go to this page. This is where I start showing you this thing called synthetic division. And some of you are going to say, I don't like it. I just want to do long division because I can do that and I'm good at it. And to you I say, would you like to be able to do long division but literally 4 times faster? Because that's what this is. Synthetic, see how quick it is compared to all of those steps? It's way faster. It's like take the difference between riding your bike to school and taking a car to school. Way faster. Okay, so let's see how to do it. First off, if they give you a factor here, you have to be careful because you want the root of it, the thing that makes it 0. You don't just copy that +1 over. You think of what makes this equal 0. -1 does, so that's what you put there. The rest of them are easier. They're the coefficients. Would you agree that there was a 1 in front of that x to the 3rd, which then I already drew over here, and I should erase it so you can see. There's a 1 there. 2 here, 2 here, -5, -5, and -6, -6. That's where you get the numbers from. Now here's the calculation part of it. Zoom in on this. You don't have to do anything. Just watch for a second and see how I do this. I'm going to quote 2 rappers today. The first one, Snoop Dogg. Drop it like it's hot. That one drops down, and I can't explain to you super well why. It just drops down. So drop it like it's hot. That's it. Drop that one down. I'll explain later how that kind of makes sense mathematically. The next thing is not doing that 2 minus 1 because you wouldn't have known where this came from. So this was the first thing you do is drop it like it's hot. Then you multiply by this. 1 times -1 gives you that. -1. Then you combine the 2 and the -1 and you get this 1. Then you go back to multiplying again, which gives you that -1. Then you combine these together and you get -6. Then you multiply by -1, makes +6. And then you combine these together and you get that, which is the remainder. Now I know, that seemed insanely hard. It's actually not. Let me show you. Please go off to the side. Put a 2. Put a 1, 3, and let me just think for a second. And a -10. So if you just set up your problem would have been, by the way, does x minus 2 go into x squared plus 3x minus 10? That would have been the question. Okay. Are you ready for this? See how that 2 came about? See how the 1 and the 3 and the -10 came about? Okay, now, Snoop Dogg, drop it like it's hot. Multiply. 1 times 2 is 2. Add. 3 plus 2 makes 5. Multiply. 5 times 2 makes 10. Add. -10 plus 10, 0. That is the remainder, and I'm walling it off for a reason. The remainder is 0, and that means it worked. And what is the answer then, Mr. Server? The answer is x minus 2 for this part, and x plus 5 for that part. How did I get the x plus 5? Because this is the constant. It's the last number right there. And then this number gets an x. If I had another number here, like let's say there was a 3 there, then that would have been the x squareds. And if there was like a 5 here, that would have been the x to the thirds. And then if there's another number here, it would have been the x to the fourths. All right. You'll see as you do a couple more. But now, do you get that that times that right here, this actually equals that? It actually works. We just factored it using synthetic. And look how quick it was. Once you set the problem up, that's all your work. It's like writing 6 things, I guess. That's a lot faster than long division. All right, moving to this page. So, did you see how to set that up? On the left side, you have a normal long division problem. On the right side, can you do it with synthetic, which will go literally 4 times as fast. First off, really common mistake is for people to put -3 here. It's actually +3. Remember, it's what makes this part 0. And then it's got a 2, a -1, and position the -15 right above the box, because that's what's going to hold the remainder. Hopefully the remainder is 0. And I can tell you on this one, I'm 98% sure it is 0. Excellent. Somebody's verifying that it is. Drop it like it's hot. Now, if I was going to explain this without a wrapper, I would say that the 2 is being combined with nothing, which gives you 2. Then you multiply. 2 times 3 is 6. And then the -1 is being combined with the 6, which gives you 5. And then the 5 times the 3 makes 15, and then they're combining, and you get 0. Yay, there's a remainder of 0. Can you interpret it? X minus 3. 5 goes here, and this must be 2x plus 5. There we go. See how fast that is? That's why synthetic is even useful. Because you can do all the problems with long. Now, if you're like, but I'm going to actually do this instead of long division every time. Nope. There's some that only long division can solve. Like there's some problems you can't do synthetic on. So you need that. It's a powerful tool. Long division is still a powerful tool. And I can show you an example of one where long division could do it. Don't write this down, please. When there's weird stuff out here, then you can't use synthetic. You'd have to do this with long division. And it could theoretically be done. It'd probably have a remainder, but you could do it. Okay, so synthetic is important, long's important. But if I had to pick, long's more important because it can do every problem on the test. I don't think we even tell you that you have to use synthetic on any problems. We do tell you you have to use long on some problems. Synthetic is just faster and it's better and you're all going to want to use it. Just trying to say that if there's a boss, the boss one is long division because it works on even the hardest problems. It's kind of like solving a quadratic. Factoring is awesome until all of a sudden it doesn't work. What's the boss for solving quadratics? Quadratic formula, because it solves anything, including imaginary answers that don't factor at all. Yes?
Well, where do you get the 2 from the 2x plus 5 from? In the solution.
Okay. See this 5 here?
Yeah.
That became the constant. Whatever's to the left of that is the x's. And if there had been another number, let's say there was an 8 here, that would have been x squareds. Sorry, losing my voice. All right, let's get to this yellow page. See if without my help, you could do a typical test question. You are in honors, so of course there's one more tricky thing today. It's coming up. Let's master a normal one first. You would put in -8, and I get it. You're like getting used to it's always the opposite of the thing that's there. If there'd been like an x plus 7, then you would have used -7. But since they said that this is the solution, then you use the -8. See, they didn't give you a factor like this. If they had, then you would have switched it. All right, 2, 10, -46. Can you verify it had a 0 remainder? Some people are nodding. Maybe you aren't all there yet. Some people are shaking their head. All right, let's find out. 2 drops, multiplying, combining. Let me think. My brain just broke. -6. There we go. 6 times 8. Ooh, 48. I bet somebody just got caught on that. They were like, 6 times 8 is 46. No, it's 48. So this has a remainder of 2. And it's actually the easiest kind. So then you get to say, is this a solution? And you say, no, because it has a remainder of 2. You can't just say no. But you got to say no because there's a remainder of 2. All right. One more thing, and this is important. How do you write your answer when there's a remainder? X plus 8, remember that's kind of the opposite. Then this part, 2x minus 6, and you might be like, what's the point of that? Doesn't work unless you add the remainder. I'm going to remind you of that deal from when you had 7 into like 20, and 7 goes in there 2 times is 14, and then there's 6 left over. You could say that this was 7 times 2 plus 6. You add the remainder at the end. So look, I added the remainder at the end. All right. We're all... Oh, wait. One more thing. Almost done, boys and girls. This one is the last normal one, and frankly, I think you get the normal ones. So we're going to skip it. Go to the green one, because it's not normal. We have to be able to understand how to handle it when it's not normal. When you're out hunting in southern Minnesota and you're hunting for deer, and all of a sudden there's a giant herd of pigs. Not kidding, this actually happened to people this year. Did you know that Minnesota is one of the states that's being slowly overtaken by wild pigs? I'm not kidding. You could go for a walk and run across feral pigs. Are they friendly? They're very not friendly. In fact, they have very sharp teeth, and they can chomp you. And if they feel threatened, they will chomp you. So you have to know what to do. Did you know that it's legal? Basically, they're an invasive species. So like carp, they're not supposed to be here. You can catch all the carp you want. All right, anyways, what do we do when it's not normal? Here's the answer. First of all, you go 3, and then you go, there's a 1 there to start with, that's all normal. But wait, there's no x to the fourths. 0x to the fourths. Negative 11x to the thirds, 5x to the seconds, 8 regular x's, and negative 15. See if you can do that. It's really not that hard. It's just a bunch of multiplying and adding. We're technically combining, because sometimes you're subtracting. Drop it like it's hot. 1 times 3 is 3. 3, 9, negative 2, negative 6, negative 1, negative 3, 5, 15. You can usually know that if it comes out to 0, the probability you messed up and happened to hit 0 is pretty slim. So I would say if you got 0, you probably did it right and it worked. Yay. But can you interpret your answer? I said I was going to quote 2 rappers today. I've only quoted 1 so far. Snoop Dogg. I bet you can't handle the excitement of figuring out how I'm going to quote another rapper. I'm sure some of you can think of some things that I could say that would probably get me an early retirement from teaching. Don't worry, I'm not going to be saying any of those things. Quotes from rappers that are totally inappropriate for school. But this one is from the great rapper Ice-T. And he said, "Check yourself before you wreck yourself." Famous line from a rap. I'm checking that. You know what for? To see if it could be factored. How would you ever be able to factor something that big? Imagine a world where your final answer had come out to this. And you're like, okay, I factored it. And then you're like, no, I didn't factor it because I just checked it and I realized, do you guys know what can be factored? X plus 1, X minus 1, yes. And do you remember factor by grouping? Do it. This is exactly the kind of thing that happens on the test. It can be factored in 2 different ways. Could be like the difference of squares factoring, but what about that factor by grouping thing? I like to call it divide and conquer, because it has a historical lesson built in.
I'm ready to do it.
The one that's on the screen right now is a brand new problem that has never been seen before. I was saying, imagine this happens on the test and you didn't check yourself. You would have definitely been wrong because it can be factored twice. That part can be factored, and I'm low-key reminding you that you have to know how to factor by grouping for the test. X squared comes out, x plus 3. X comes out, x plus 3. Coincidence that they're the same? No, of course not. I've heard people say there are no coincidences.
The second one would be 2x comes out.
Thank you. All right. Nope, it's just 2. It's just 2. I believed you for a second. You got me. Okay, and now the x plus 3 gets factored to the front because that's the common factor. What's left behind is the x squared plus the 2. And then don't forget these guys. I'm going to bring them down right here. And now if you were asked, how many real roots did you have? What would you say? 3 is correct. How many imaginaries? 2. 2. Do you remember the deal on imaginaries? They always come in sets of 2. If you do understand that, wait, that's a bad example. I'm going to give you a different example. That's the old x to the third graph. Remember that? I only see one real root. But Mr. Server, you earlier said that the fundamental theorem of algebra said that that had to have 3 answers, and yet there's only one. There's only one real one. There's one real one and what? There's 2 imaginary answers. That's a possibility. That is a possible answer to that question. Even if it was like that could have 1 real and 2 imaginary answers. There's for sure 1 real one, though. I can see it. It's 0. But there could be 2 imaginary answers also that I can't see. Because you can't see imaginary things. Unless you're in the movie Signs. Spoiler in case you've ever seen it. All right, so let's get to this one. Is that a factor of that? Well, it's got missing terms. Can you handle it? If you can handle it, you should be able to finish this in less than a minute. Do synthetic, it's way faster. If you didn't put in those 2 zeros, you didn't catch that this is technically x to the third plus 0x squared plus 0x minus 8. Drop it like it's hot. Double checking myself to make sure I didn't mess this up. Because I'm getting that it doesn't factor. Does anybody else get that it doesn't factor? Because I'm getting a remainder, so I'm just double checking myself. Rut-row. Oh, I was adding. Dang, I was adding. That's supposed to be a 4. That's where my mistake is. Yay. It does have a remainder of 0, and therefore it does factor. I felt like that was wrong, so I'm glad you guys found my mistake for me. That's going to happen to you too. If you're like, does this thing really not factor? Because remainder of 0 is really rare. Okay, so good. Good job. Then this final answer is x minus 2 times, well, that's the remainder, so you kind of like block that out. That's the x's, that's the x squareds, because that's the constant. And did you follow Ice-T's advice? Check yourself. Could that possibly factor? It could possibly factor. Does it actually factor? 2 times 2 makes 4. I'm pretty sure that would make a 4x in the middle. A 4 and a 1 is not going to make a 2x. I don't think that factors. Now, just to clarify, just because it doesn't factor doesn't mean it's imaginary. It just means it's not whole numbers. Do you know how I could find out the solutions to that if it doesn't factor? If you can factor it, you should. What if you can't factor it? Quadratic formula. The quadratic formula could solve that and tell you whether there's imaginary solutions or they're real. Because quadratic is the boss formula. It can factor, it can solve any quadratic. Okay, you've made it to the end, boys and girls. Now open up the homework and it says right in the name of the homework that you're going to do problems 1, 2, not 3, 4, 5, and 6, and there's more after that, so you can skip the rest of those. So again, this is actually a cut down from the normal amount. So you can cross off problem 3 and all the problems after 6. Cross off problem 3 and problems, I think, 7 and 8. Whatever's after 6. Okay. Number 1. Sophia, could you read that to me, please?
Is x equals to a factor of y?
Wait, x equals 2. Okay, so I'm going to put 2 here, and then what? I'm going to just write exactly what you said. X equals 2 is the...
Is a factor of y equals x to the 3rd minus 16x squared plus 28x.
Did you guys catch that there's a missing term? Yes, you have to put that plus 0 or it won't work. I think you should just always, if there's missing terms, put a 0 in. I showed you on there's one kind of problem where you can kind of get away with it without having the 0 to hold the place, but it's better to just have the 0 to hold the place, because when you're doing synthetic, you have to have placeholders. It won't work at all. 1, negative 16, 28, and 0, and you draw the line and drop it like it's hot. 1 times 2 is 2, add them negative 14, multiply them negative 28, add them 0. 0 times 2 is 0, 0. And the reason that that extra 0 matters is then because that's the remainder. That's the constant. So my answer will be x minus 2 for this part. And then that's the constant. That's the x's and that's the x squareds. So I got 1x squared minus 14x. Do I really have to write plus 0? No. Did you check yourself before you wrecked yourself? That factors again. There's an x in both of them. I'm warning you. Almost guaranteed to happen on all the hard problems of the test. Is you get done factoring and then you realize, oh, I can factor it even more. Do you have to put the x in parentheses? No. Could you put the x in the very front? Yes. If you wanted to. It's not required though. And then here's one last little gotcha. Some people are like, the answer is 14. The answer is 2. And the answer is 1. No. It's 14, yeah. It's 2, yeah. And then what's this last one? 0. Good. The question is, what can you stick into it and make it equal 0? On this one, it's 14. On this one, it's 2. And on that one, it's 0. So there's 3 answers. They're all real, too. Some people get confused by 0. 0 is a real number. All right. Now, if they asked me for how many real roots, I would have said 3, and here they are. If they asked me about imaginaries, I said there aren't any. When are there ever imaginaries? If the answer looks like this at the end, watch out, because the only way to solve that is with an imaginary number. Anything that looks kind of like that, they're normal. Those are real kind. This is the imaginary kind. All right, that's all I have for you for today. Remember, it's problems 1, 2, skip 3, 4, 5, and 6.